Hope you are able to see my screen.
Yes, now it is come. Yes.
So today we will discuss about how part.
Yeah.
Because just knowing the things is not enough.
Yeah.
We need to know how we can implement,
Correct.
how we can use that,
Yes.
or what are the steps which we will need to take care
Yeah.
while we are implementing.
Correct.
Okay. So for that means whatever we learn,
Ah.
we need to think in a same manner.
Ah.
Means we learn about this observability,
Mm.
and we discuss about logs, we discuss about metrics, we
Yes.
discuss about trace,
Yes.
right?
Yes.
And means for how itself, we need to take this as a separate unit, each and everything as a separate unit, and think more about that,
Yeah.
which is which I told you so many times.
Ah.
This is a way to think in a you can say design or architect manner.
Level. Okay. Okay.
Okay, so first we need to start with the observability.
Ah. Ah.
Am I
Ah.
right?
Right.
For observability, definitely we need to identify
Mm.
means which
Mm.
flows of our application or business we
Mm.
need to capture.
Right.
Am I right?
Right. Right.
We need to capture,
Mm.
and there also means while capturing this, we
Mm.
need to know this means what which you can say event we know,
Mm.
and what is the you can say failure there.
Mm. Mm. Mm.
What is the failure there, and you can say after failure
Mm.
means what you will do there.
Mm. Mm. Mm.
Am I right?
Right.
Like how to start observability design, identify critical user flow.
Mm.
Okay.
Yeah.
And then what went wrong is, and what you need to see.
Mm.
If
Mm.
something went wrong, what you need to see there.
Mm. Mm. Mm.
Okay.
Okay.
And you can say then we will, when we have that,
Mm.
then we require a means it should be before production. It should not be when we encounter some problem or occur, then we will going to do this. No.
Ah. Ah.
We
Ah.
should do well in advance.
Right.
Okay.
Right.
And you can say we need to connect this with
Mm.
the business, because
Mm.
end of the day we are targeting a business.
Mm. Correct.
Am I right?
Yes.
So same thing means this is a observability, means this is a for observability. Now,
Mm.
as we discussed, we need to work on a individual level. Now we
Mm.
will move forward for a
Mm.
logging.
Right.
Log.
Okay.
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 So as we discussed in a concept part, we
Mm.
cannot blind, we cannot, you can say, log everything.
Okay. Yes.
We need to means log meaningful events.
Ah. Ah. Correct.
Am I right?
Yes. Yes. Yes.
Not everything meaningful,
Mm.
and log should have a some, you can say this,
Mm. Mm. Mm.
uh, structure as well.
Right. Right.
Which structure we are going to follow.
Mm.
After structure means we need to know the context as well.
Ah.
Context also should be there.
Yes.
You understand my point?
Yes. Yes. Yes.
After context, you have a, you can say this should be consistent throughout the service. It cannot be, you can say, one
Mm.
service is changing and another service is doing taking me using another program. No,
Right. Right.
which are confusing, and we need to be you can say low
Mm.
secrets.
Mm. Mm.
Okay,
Right.
so these things we need to consider while we are logging,
Mm. Mm.
which we discuss and check this in
Mm.
this
Right.
document only.
Yeah.
Now we have observability. Now we have a log.
Mm.
Now next step is, you can say, this metrics. we require. Am I
Yeah.
right?
Yeah.
With the help of that, we can compare.
Ah.
And those are means as it's called metrics. So first we need to categorize.
Yeah.
What is the category of this matrix? How we can divide this into category?
Yes.
Because if we will divide the things in a categorize or group, then we can think logically and have a better control. You understand my point?
Yes. Yes, Deepak. Yes, correct.
After deciding a category, we need to means define a matrix
Right.
which have a meaningful. You can say this. Okay.
Mm. Mm.
After doing that, we after deciding this category means a category and deciding a matrix.
Mm.
So we need to know what means what matters
Mm.
there and what means how we can communicate
Mm. Mm.
the things. Okay,
Mm. Mm.
and then means after communicating the things, how we will detect the failure
Mm.
early.
Mm. Mm. Mm.
So this thing also need to be taken care.
Ah.
Okay,
Right.
and then because nowadays we working on a traceable this distributor system,
Ah. Ah. Ah.
so we need to think of traceability as well.
Right.
Okay, for traceability means we need to, you can say, know the whole, you can say, transaction or
Mm.
whole
Mm.
flow of the transaction,
Right.
and how you can say it's moving from one service to another, and
Mm.
what are the, you can say, ID or consistency we can use so that
Mm.
we can link the
Mm.
things
Mm.
together.
Right.
After doing this observability, doing this, you can say, this thing,
Mm.
uh, the end goal is you means our developer, our team can be is feel confident and feel comfortable
Mm.
and easily, you can say, find the bug issue whatever we are encounter on a means when on a production.
Right.
Okay,
Right.
so now after doing this, we require means we implement everything.
Mm.
But if it's a overthink
Mm.
and overuse, it's a, you can say, we need to make a balance of that user.
Mm. Mm.
We cannot apply this alert for everything.
Okay.
Right?
Okay. Right.
We cannot means whatever importance
Mm.
you can say events are there, we can apply, and those should be actionable.
Correct.
If we are not getting an answer, what is next step?
Mm. Mm.
Then it's a useless. Am I right?
Correct. Correct.
And we need to go with the
Mm.
debuggability as well.
Ah.
How
Ah.
we can make it debuggable.
Okay.
You understand my point?
Right. 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 Right.
Because if we talk about this, we talk about our program,
Mm.
then in a
Mm.
single flow,
Mm.
means so many files are involved.
Mm. Mm. Mm.
From some file we are calling a method, some file we are calling a service. So
Yes.
many things are
Yes.
interrelated. So problem can be occur any. So if
Mm.
you don't have that debuggability, means how you will debug.
Mm. Mm.
Am I right?
Correct.
So then means even though after implementing this thing so much, we don't have any clue.
Mm.
Means
Mm.
what are the steps we need to take care?
Right. Right.
You understand my point?
Yes. Yes.
That's also important.
Mm. Mm.
And means for that,
Mm.
most important, dashboard.
Ah. Okay. Okay. Okay.
You understand my point?
Yeah. Yeah. Yeah.
We implement everything perfectly, but visualization is not there.
Yeah. Correct.
The visualization is not there, and you can say we are not able to see
Yes.
what is going wrong. It's
Mm.
going wrong with the database. It's going wrong with our API code. It's going with the front end.
Mm. Mm. Mm.
So that's also a problematic.
Mm.
Right.
Mm. Correct.
We require test,
Yes.
but as requested and discussed so many times,
Mm.
don't go blind.
Ah, yes, correct.
You understand me?
Yeah, yeah.
So with all this, you can say mindset,
Mm.
and we will move forward and check this.
Mm, mm, mm.
Are you ready?
Yeah, yeah, definitely.
Okay, go ahead, please.
Okay. Yeah. So how to engineer observability and monitoring in real systems? Okay. Why this part matters? Knowing that logs, metrics, and traces exist is not enough. Yeah, correct. In real system, the important question is how to design observability so engineers can detect issues early. Yes. Understand failures quickly and operate system confidently under real production load. This model explains how to engineer observability and monitoring step by step so the system behavior becomes visible, measurable, and debuggable from day one. Yes. Okay. How to start observability design? Okay. Identify critical user flows. Correct. User login, then place order. Make the okay. First user login. I login. Place the order. Make the payment. Assign delivery partner. Send notification. Generate the invoice. Yes. Observability should begin with the business critical flows, not random technical signals. Okay. Okay. What can go wrong? Fine. Ask what can go wrong. For each flow, think about where latency can increase, where failure can happen, where a retrace may occur, where dependencies can slow down, where data may get stuck, where silent degradation may happen. Okay. See, where the last point, Deepak, where silent degradation may happen. How do we can we make it an example? Say slow degradation. One is like, for example, anyway, that we already get. For example, when the number of users are increasing, we know gradually there will be a little less performance. But here, silent degradation may happen. Uh, this example is okay, like when the number of users are increasing day by day. In the background, performance may slowly come down.
No, you can think of degradation mean, let's say we have this 10 services are there. Am I
Ah,
right?
okay, okay.
And means rather than 10,
Ah,
nines are only working, 10 is down.
oh, okay,
You understand my point?
okay, okay.
Means one person stopped this working.
Ah, ah,
That's
ah,
a degradation.
ah, ah.
Means if let's say some means let's say you are frequently getting a order. Am I right? Of a one dosa, idli and thing.
Ah,
But for this paratha, you don't have order. Am
okay,
I right? And you are
right.
not taking care of that. Am I
Ah,
right?
ah, ah.
Because it's not a too much used. Am I
Yeah,
right?
right, right, right.
So it's a silently degrade may happen. Means you can
Oh,
think of
ah,
means silently. You are
okay,
not taking care, and it's a means degraded done because you are not doing that.
okay,
So you not means take care of this part while
okay,
you are designing. Then
okay,
it's missed.
okay, okay,
You
okay,
understand my point?
okay, 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 fine, okay, right. Then decide what you need to see. Okay, events you want logged, correct. Measurements you want tracked, right. Then requests you want traced, thresholds that should alert engineers. Yeah, beautiful, perfect, yes. Then design observability before production. Yes, API design, service design, asynchronous workflow, deployment planning. Yeah, right. So connect technical signals to business impact. Do not monitor only CPU and memory. Also track order success rate, payment failure rate, delivery assignment delay, notification success rate. Okay. Food delivery example. For place order, observability should capture request received, validation success failure, payment call latency, order creation result, then even publication, downstream delivery assignment delay. Okay, fine. So how to design good logs? Logs, important events, not everything blindly. Log, correct. Request started, then request failed, state change, dependency timeout, retry attempted, message sent to the queue, payment declined. Oh yeah, these are logs we need very much. Okay, fine. Um, okay, avoid useless noisy log for every minor internal line of execution. Yes, correct. Okay, use structured login. Log should be mission readable and consistent. User useful fields, timestamp, service name, environment, login, log level, request ID, correlation ID, user ID or order ID were appropriate. Error code, very important. Error code is very, very important. Okay, everything is important, but fine. Dependency name, dependency name, then state transition, state, yeah, okay, state transition, okay, fine. Then add context for debug. A log without context is hard to use. Correct. Payment fail. Better. Service equals to payment. Service order ID equals to okay, correlation ID, then error code, then dependency, gateway, retrievable true. Okay, fine. Oh, this is the context. Fine. Then avoid logging sensitive data. Yes, passwords, then username, maybe raw tokens, payment secrets, is personal identity details unless properly masked. Internal secrets. Yes. Okay. Keep log format consistent across services. Consistent naming makes cross service debugging much easier. Example: order service, payment service, delivery service should you all use the same field names: correlation ID, request ID, order ID, error code.
I
Correct.
I have one question
Ah,
on this point.
ah,
Let's say it's means we keep log format consistent across services, am I right?
ah,
Let's say you are using third-party services, then
ah.
if you're using third-party services,
Okay.
how you can achieve that? You are able to achieve that there or not?
For example, payment is a third-party application where API we are using. Payment.
Yes, payment you can say you can consider payment, you can consider notification service, you can consider SMS gateway, many more.
Mm, mm, mm.
Am I right?
Yes. But even though it is a third party, definitely that API will be uh, having uh, that the request has come from where, and then uh, okay. See, yeah, again, order ID, the name may not be order ID, but because that API can be a generic API used for various purposes. Ultimately, it is a payment service, but it may have some other naming conventions which we have to convert that to our naming convention, like correlation ID, request ID, order ID, error code. For example, order ID may not be the same for the other application using the same API. But so we should understand the what we say, the pattern or the context what they are giving, and then convert that to our requirement.
No, you
No?
can think of it as simple.
Ah,
Whatever means things we're going to use.
ah,
Definitely means input is in our hand. Am I right?
Input is in our hand, yes.
Yes, and when we don't need to care about you can say their processing, but
Oh,
input in our hand and
okay.
output we also get output,
Okay. Oh, okay.
which we need to take care only those things.
Okay.
Rest of the thing we don't need to take care what they
Read
are
about-
doing
Oh,
under the hood, what they are not doing. Why we need to change? We need to maintain that everywhere. You understand?
okay. Okay.
Whatever in our control.
Ha, 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 ha.
You understand my point?
Okay. Okay. Uh, Deepak, see now, if you take payment, okay, through my app, I'm calling the payment, I'm passing, my input will be like, this is the order ID, this is the quantity, this is the amount. So amount part is that should be deducted is what I convey through my app. I pass this information. Now the same app, if it is called in some other routine, there also, yes, instead of order ID, it may be something else. See, I'm thinking of, for example, in a different industry, say in a factory environment where I want to purchase some items. Yeah, there also everybody. I mean, everything will have an order ID and then the quantity. Yeah, yeah, okay, you're right. Okay, fine, got it. So, what input we give matters a lot. Correct. Okay.
Yes. And
Yeah.
what output we will get because we need to do that only.
Ah, ah, ah.
Because from input we will trace, hey, this is the things which we
Mm,
will give an input, and based on input, this output we will get. With the
right.
error or not.
Ah, 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 ah.
You understand my point?
Right, 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 right. Okay, fine. Then how to design good metrics? Choose core metric category. At minimum, monitor traffic, latency, then errors, then saturation. Here, saturation, Deepak, saturation. I think we discussed once, but I forgot. Saturation.
Saturation means you are whatever capacity you have, you are saturating that.
You'll have,
You are not utilizing the full power.
okay, okay, okay.
Mean, let's say you have the CPU is capable to handle 8 requests parallel, but
Ah, ah.
it's not handling 8 parallel, it's handling 4 or 2. This is saturation.
Oh, okay, okay, okay. Add business, okay, this gives a strong baseline for service health. Okay, add business metrics too. Technical health is not enough. For example, order placed per minute. Yes, okay. Payment success rate, delivery assignment success rate, cancelled order. Cancelled also. I was thinking long. Okay, cancelled order percent. Okay, how many orders get cancelled? Okay, fine, right. Then measure latency distribution, not just average. Measure latency distribution. Okay, fine. Average latency. Oh yeah, P50, P95, P99 latencies. Okay, fine. Okay, fine. Average alone hides bad user experiences. Okay, fine. Right. Okay.
You understand this point?
Yeah, correct. Average alone hides. Yeah, only average is not sufficient. Correct. Okay, fine. Then measure error codes clearly. Okay, use useful error codes for the okay, WX rate, YWX rate, dependency failure rate, then timeout rate, then retry rate. Yeah, yes, this is also very, very important. Correct. Okay. Track resource saturation. Okay. CPU usage, memory usage, queue depth, thread pool saturation, DB connection usage, then cache pressure. Okay, fine. Okay, for order API, example, order API, useful metrics include request per second, success rate, P95 or P99 latency, payment timeout count, okay, and then DB, it come down, DB query latency, yeah, order creation success percentage, okay, right, fine. So how to design traces in distributed employee systems? Okay, trace critical requests end to end. Any request that travels through multiple services should be traceable. Example: place order, login flow, checkout, refund, then partner webhook handling. Webhook, I think read some. Okay, partner webhook handling. One small brief I need Deepak on that webhook. That keyword.
So basically, when you are means interacting with a third party,
Ah,
okay, then they will not expose everything. Whatever they look means whatever they will expose, they
ah.
give you some callback to you.
Okay.
If it's a success, you will get the success in
Mm,
this manner, and in this portion, you will get a success.
okay.
And if there is a error, this is the error block.
Uh, uh, uh,
And means if there is a step-by-step process, they will give you one method with the help that you can identify which steps we are working on. Am I right?
right.
So it's you can say hooks,
Uh, uh,
which you will get when something is happened there. Am I
okay.
right?
Okay. Okay.
You can think of callback methods.
Okay. Fine. Okay. Okay. Right.
Understand my point?
Okay. 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 Okay.
Because under the hood, what they are doing is under abstraction. They not
Right.
expose that.
Right.
As
Right.
I told you, not you need to take an input and output, and in an output as well, they will tell, hey, if you want to listen this, you need to extend our this class and this method, you will get these values. You can override as per your control.
Okay. 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 Fine. Right. Okay. Propagate trace context across the services. Every downstream service should continue with the same trace context. So the full request story stays connected. Yeah. Beautiful. Right. Create meaningful spans. Okay, each important step should become a span, such as API gateway processing, request validation, database query, payment service call, inventory update, event publishing. Okay, fine. Capture timing. Yeah. Start time, end time, duration, dependency name, outcomes or error status. Yes, correct. Use traces to find bottlenecks. Yeah, traces are especially useful for slow dependencies, long database calls, retry storms, queue delays, fan out bottlenecks. Right. Example, a please order trace might show API gateway 15 milliseconds, order validation 20 milliseconds, payment service 1020 milliseconds, DB write 35 milliseconds, even publish 10 milliseconds. This makes it obvious that the main latency comes from the payment services. Correct. Okay. How to detect failures early? Define what normal looks like. You must know normal baselines for request rate, latency, error
Hold
rate.
on, hold on, hold on, hold
Yes,
on.
yes,
Yes.
yes.
Now you understand whatever
Hmm.
I told you.
Yes, yeah, yeah, yeah.
Granular,
Yes,
granular level.
granular way. Correct, correct.
Now you are able to see
See, 1020 milliseconds payment services. That is the bottleneck there. Okay.
which you need to take care.
Yes, correct. Okay. And also they should be consistent. For example, in the sense, let's say now, for example, 1200 milliseconds happens consistently. If it is once in a while, like if it's a spike, I think we can ignore. But if it is for every payment, okay, in a day, let us say there are around, we say we have around 500 payments in a day. Out of 500, if majority of the time the delay is 1200, then we need to really look into it. Out of 500, for example, first one or two I may get, then maybe after 200 200th order I may get once or twice, and maybe in the last one, I may get again once or twice this delay. So I did not bother much about those patterns, right, Deepak?
No, let's say someone complained to you. Hey, earlier everything is going fine.
Ah,
Now means my means application is not means working as expected. I mean,
ah,
then we need to debug.
oh,
So for that, for debugging, we need to do this. We
ah,
need to analyze each and
analyze,
every component. Okay. You are thinking in a different manner. I am saying it's a different scenario. It can
oh,
be complained by your user. Hey,
okay,
I'm getting a means I'm not getting a response,
okay, okay,
or I'm getting a response after so long time.
oh,
Earlier it's means coming a second. Now it's coming in a you can say this millisecond. Now I'm getting in a second means more than that.
okay,
Let's say 5 second. Now I'm getting in a 30 or this or
okay,
millisecond.
okay,
We need to debug in this manner.
okay, fine, okay,
You understand?
okay, 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 okay.
We are talking about this monitoring thing.
Yes, yes.
And if this pattern is means for me some from time from this time, then
Ah,
we can go with the work means we will work to means fix this. If
mm-hmm.
it's just you can say once in a while, then we don't need to take care. We are talking about that thing, but
Yes, yes.
I'm talking about this scenario when user complain.
Oh, user complaints. Okay, okay, okay. So after he complains, we come and analyze where the bottleneck is. Then we find that in some cases it has come to it has 2,200 milliseconds. So that is the cause of the bottleneck.
Yes,
Okay. Okay.
yes, because from our you can say this from user information only we will get that. Means what is the you can say what is the user ID, what he ordered and things because
Hmm,
everything
hmm,
in available with us,
hmm,
right?
hmm, hmm, hmm,
If
hmm.
we will get that, we can if we have this traceability matrix, we can find out easily.
Okay.
You understand my point?
Okay, okay, okay. Got it. Okay, okay. Fine. So define what, oh yeah, for this video. Okay, define what normal looks like. Or you must know normal baselines for request rate, yeah, latency, error rate, then queue depth, dependency behavior. Right. Fine. Without baselines, let's become guesswork. Yeah, right, correct. Okay. Watch for leading indicators. What are leading indicators? Important early warning. Rising p-net latency, growing queue depth, yes. Then retry increases, dependency timeout increases, sudden drop in success rate, CPU or memory saturation trend. Okay, fine. These are the leading indicators. Okay. Alert on actionable condition. Alert should point to real problems that need action. Good alert example, payment failure rate greater than 5% for 10 minutes. Yes. Okay. Order placement, P&D latency greater than 2 seconds. Delivery event queue depth rising continuously. Then 5x error rate above safe threshold. Okay. Fine. So avoid overreacting. This one, tiny spikes. Okay. Temporary fluctuations are normal. Use time windows, then sustain the thresholds, then multi-signal confirmation where appropriate. Correct. Okay. Then detect silent failures to not all failures shows crashes. Examples of silent degradation, slower database query, backlog in async query, event consumer falling behind, intermittent third-party slowness. Okay, third-party slowness. Okay, fine, right. So how to build useful dashboards? Organize dashboards around user journey. Instead of random graph, group by business flow. Order journey dashboard, payment health dashboard, delivery assignment dashboard, notification pipeline dashboard. Okay. Show the most important signals first. Okay, strong dashboard usually includes success rate, throughput, latency, error rate, saturation, dependency, health. Right. Then combine technical and business view. Order dashboard, order per minute, order success rate, P9 P95, P99 latency, payment timeout rate, DB latency, then queue backing. Right. Make dashboard fast
Hold
to.
on, hold on, hold on.
Yes.
What you understand from this P50, P95, P99? What you understand?
I mean, the that is the like keyword, Deepak. I mean, that day you told in this one. I'll tell you. Wait, one system design. That is the wait. I'll tell you the right word you used that day. Um, okay. 90, for example, when you say P95, 95% requests are faster than this.
Okay.
Okay, in that case, for 5% is slower. When we say P95, 95% of the time the requests are faster. Maybe 5% of the time it is slow. P99, 99% of the time everything is fine. Only 1% there may be a failure or bottleneck or slowness.
Yes.
Right?
So why we will measure in this manner? That's an important question for you. Understand my point?
Okay. For example, say out of 100 requests, 95 requests are done, say, within 5 milliseconds. Remaining 5 requests takes more than 20 seconds.
Okay.
So there we say it is P95. So that means out of 100 requests, 95 requests are okay. That is acceptable norms. Whatever we wanted, that's happening. Remaining 5%, we have delays, some problems. So we need to look into it. So when in the dashboard, I need to know. So maybe out of 1,000 or out of 10,000, this many requests were within the limits. This many requests were going beyond that. So we have kept this one like P95, P99, the thresholds. For example, okay, order placement P90 latency about greater than 2 seconds. Okay.
So basically means average is not fine.
Average is not fine. Okay.
Because if you lying on an average, then it's a good. But something is going wrong, and that's why we need to take care of that part as well.
That part.
That's why we are following this approach.
Right. Okay.
You understand my point?
Okay. You put up nicely. Okay, fine. Okay.
Go ahead, please.
Make dashboards fast to scan. Make dashboards fast to scan. During incidents, engineers need quick understanding. So prioritize clarity, grouping, then trend visibility, Then minimal noise. 1 minute clarity. Make dashboards fast to scan. During incidents, engineers need quick understanding. Prioritize. Okay, clarity. Here grouping, uh, trend visibility, minimal noise. Okay, so here my doubt is in the dashboard, engineers need quick understanding. Prioritize the clarity. They need to prioritize the clarity part of it in the dashboard.
Yes.
So, okay, so the dashboard should exactly tell
Which thing need to be fixed first?
first where the issue is, that issue item is. So that should be highlighted. There should be clarity in depicting that number or text or whatever it is. So they can just add.
Criticality as well.
Ah,
Criticality as well. That's
ah,
a 10 things we need to fix.
ah,
But
ah,
what is the priority there?
okay, fine. Okay, fine. Okay, okay. Okay, then add drill down path, very important for dashboards to from dashboard to traces, logs, affected dependency metrics, recent deploy markers. Okay, yeah, drill down. Yes, we need to go down to the last level. So, okay, fine. The tree-like structure. Okay, fine. Okay. An example, if payment success rate drops, dashboard should help engineer quickly jump into payment latency metrics, payment error logs. Yes, from which need to go down one by one. Okay, fine, right? Payment error logs, trace for slow transaction. Yeah, right. Okay. So how to design for debuggability? Use correlation IDs everywhere. Every request or workflow should carry a correlation ID across the services. Yes. Make errors searchable. Errors should use stable error code, consistent messages, clear service ownership, dependency naming. Right, dependency naming. Okay, stable error code, very good, correct. Consistent messages, clear service ownership. Okay, make logs, metrics, and traces connectable. An engineer should be able to move from alert to metric spike to trace sample to related logs. Yes. Record important state transaction. For workflow like order processing, log clear state movement created, or log clear state movement like created, confirm, payment failed, assigned, delivered. Oh, okay. Important state transition. Okay, fine. Design asynchronous flow to be inspectable. For queues and event-driven systems, expose queue depth, consumer lag, retry count, dead letter events, then processing latency. Okay, right. Example, a correlation ID lets engineers connect a API request log, payment timeout trace, then retry attempt log, yeah, dead letter event record. Yes, this creates one complete debug story. Fine. How to reduce alert fatigue? Alert only on actionable problems. If an alert does not require action, it should usually not page anyone at all. Yes. Prefer systems over raw noise. Okay, bad. Alert on every timeout log. Yeah, not required. Better. Alert when timeout rate crosses a threshold. Yes, business impact threshold. Yes. Tune. Tune thresholds based on real behavior. Threshold must reflect normal traffic pattern, peak traffic pattern, acceptable error budgets, expected latency ranges. Okay, group related alerts. Avoid separate noisy alerts for the same root issue. Okay, fine. Review alert quality after incident. Alert since after incident ask, was alert useful? Did it arrive too late? Was it noisy? Did it point to the right service? Yeah, okay. Example, instead of paging on every payment timeout, page when the payment timeout rate is sustained. Okay, come down, Deepak, 1 minute. Instead of paging every payment timeout, page when payment timeout rate is sustained, order success rate is dropping, p-net latency is increasing. Okay, oh yeah, only then we should, let's okay, fine. This creates meaningful signals instead of noise. Okay, how to monitor asynchronous event-driven systems? Monitor queue health, queue depth, oldest message age, consumer lag, processing rate. Okay, monitor retry behavior. Retries are useful, but too many incidents indicate unhealthy downstream behavior. Yes, correct. Monitor dead letter. Yeah, dead letter queue is a clear sign that messages are failing permanently. Yes. track end-to-end asynchronous latency, measure how long it takes from event produced to even successfully processed, right? Make events failure visible. Do not let async system fail silently. Yeah. They need dashboards and alerts too. Example, order confirmed even may publish successfully, but delivery service may lag 10 minutes behind. Without asynchronous observability, engineers might miss the issue until users complain. Yes, correct. How to build observability into architecture early. Include observability in design review. Ask what should be log, what should be log, must be where, what must be measured, what should be traced. How long will engineers debug failure here? Okay, fine. How will engineers okay? Standardize across services. Yeah, common standards for log field, metric naming, trace propagation, alert convention, dashboard layouts. Fine. Make new service observable by default. Oh, every service should start with request logging, latency error metrics, trace support, health pain points, dashboard hooks. Okay. Instrument dependencies explicitly. Important dependencies include database, caches, queues, external APIs, internal services. Right. Trace observability is a part of reliability. Okay. A service without observability is harder to operate reliably, debug safely, and scale confidently. Right. Step by step, real life food. Okay. Food scenario. Okay. Fine. A user places an order and payment starts timing out intermittently. Step one, request enters API gateway. Gateway records request count metric, latency metric, request log, trace route span. Okay. Order step number two, order service validates request. Service logs validation, results and updates trace span. Okay. Payment service calls happen. Yes. Trace captures dependency timing, metrics records payment latency and time out rate, logs capture retry attempt if they occur. Then systems are degrading. Yeah. Signals appear. Payment time out rate increases, payment latency increases, order success rate drops, retry increases. Alert fires. An alert triggers an alert triggers because timeout rate and peanut latency because threshold for sustained duration, right? Engineer opens dashboard. Dashboard shows order placement degradation, payment dependency slowness, error rate rise. Right. Engineer open trace samples. Trace shows how request time is spent in payment service call. Traces show most request time is okay, fine. Engineer opens related log. Yeah, correct. Logs confirm timeout and retry pattern with correlation ID. Yes. Team acts quickly. Okay, they may switch to degrade mode, reduce the retries, reroute dependency if possible, notify affected teams. Yes, recovery is verified. Metrics improve, alerts resolve, and traces show request path returning to normal latency. Okay, there's so many things are there. My God, okay, beautiful. Okay, oh, the dependencies. Okay.
You can check this diagram.
Yes, yes, yes. Yeah. Okay. Payment service. Okay, little. Okay, fine. I think. Payment service. Okay, I go to logs and metrics. Then trace signals. Okay, fine. Then here order service. You have delivery service. You have logs and metrics. Correct. And then okay, delivery service again branched into logs. Okay, fine. Okay, sir. Order service. Then okay, everywhere logs. Okay, logs. Okay, fine. Traces. Okay, trace span metrics. Okay, user request. Okay, API gateway. Again, or okay, it goes like that. Okay, fine, fine, fine. Okay, failure detection. Yes. Okay. Then traces connected. The latency or error pattern changes. Then threshold cost. Then alert targeted. Alert triggered. Then engineer then okay, fine. Before we request, yes. Visual correlation, ID, correlation ID, debug path, yes, okay, fine. API gateway log, order service log, payment trace, alert event log, then order processing log, okay, yes, okay, fine, right. Common engineering mistakes, yes, adding only logs, correct. Logs alone do not provide quick and visibility are request for it. Monitoring only infrastructure, CPU and memory are useful, but they do not fully showcase, show the user impacting on the front, correct. Ignoring tail latency. Average latency hides the slowest and most painful requests. Okay. No correlation ID. Yeah, what is the use? Correlation debugging becomes slow and time consuming. Yes. Too many alerts. Yes, we don't need poorly structured logs. No asynchronous observability, no business metrics. Yeah, integrity. Okay, friend, right.
Online.
One line implementation summary. To engineer observability well, instrument critical flows with logs, metrics, traces, and correlation IDs. So failures becomes visible early and debugging becomes fast and reliable. Okay. Deepak, now, okay, can stop the recording.